Hello everyone. So today we are going to start and I would like to show that how we are going to measure the relative density for preparing the samples. And here we are having three containers of known volume. The volume of this container will be known by measuring the diameter and height of the sample, and whatever the amount means basically a proportion of weight that can be taken and filled inside these containers will be taken out, and this will be used for measuring the relative density, which will be further used for the determination of cyclic triaxial test, in which we will be performing cyclic or maybe static for preparation of these samples. So this container will be first filled, and a known volume of sand will be taken. Then after this, that sand volume which has been taken will be kept here, and this is a funnel, and in which what we will do, we will first fix this height. You can see this is a movable setup, in which first we would like to say we will fix the sample at 5 cm of height, and whatever the weight which will be collected inside the box, these are the boxes or basically the same containers, whatever the weight will be filled inside these containers at this level of height will be recorded, and simultaneously we will keep on increasing the height. This height will be keep on increasing. For example, we will first take 5 cm, then 10 cm, 15 cm, and so on. We will keep on increasing this height. The amount of sand which will be filled inside the given volume will keep on increasing. Suppose we are having at the 5 cm level, a particular amount of weight will get filled inside this known volume. As we keep on increasing the height, in the same volume, weight of the sand will also keep on increasing. So we will have this weight and volume. So it will ultimately give the unit weight, and some of the setup which is called relative density setup. From there we will be finding Emax and Amin, and from this unit weight we will also find out the void ratio at the in situ condition. In situ condition means the void ratio at the present scenario. So by finding out the relative density, we will be able to find out the relative density at this stage, and this will be plotted against the different height. So whatever the height, whatever the relative density we have found out at the 5 cm level, 10 cm level, that will keep on increasing and that will be plotted. So this will be used as the relation which is in between height and relative density. So that is the main objective, and when we will have to fill or we have to prepare the sample at a particular relative density, we will directly opt out the height for the corresponding density, and we can directly prepare the sample. So this is the simplified procedure for determining the relative density height relationship. That's so first we are going to measure the volume of this container, and we will take the height first. So you can see this is nearly 3 cm of height, that is visible, I think. 3 cm of height, and inner to inner diameter is approximately, you can take it as 5 cm clearly. This is nearly 5 cm, and now diameter of diameter is of 5 cm and height is of 3 cm. So we will use pi by 4 d square h. So we'll get this volume as 58.9. So volume is 58.90. To find out the exact unit weight, we will needing this weight of the soil field. So first we'll be having this container, and we'll find out the weight of the empty container, which will be termed as W1, and we'll fill this container along with the soil or sand, whatever we'll have, so that will be termed as W2, and the soil filled, actually the weight of the soil that is being filled inside the container, will be W2 minus W1. So this is our empty container, and now we are going to place this on weighing scale. So you can see this is nearly 334 approximately.
अब क्या करेंगे?
So this apparatus is being fixed at the height of 5 centimeter. Now we will apply the sand. We will pour the sand into this funnel, and we'll wait to get this container to get filled completely. So right now you can see we are very gently pulling the sand, and this container is being filled. We will try to fill this very uniformly in terms of very small layers.
Start.
So here is the container which is being filled with the soil, and that has been filled from the height of 5 centimeter. So here you can note it down the weight. It comes out to be 420.5 container, which is 421 gram. So the weight of soil filled, which is 421 minus 334. This is the amount, which is 87 gram of sand is being filled.